Now we move on to Lab 4D, where we talk about Pandas series. So Pandas is a package which we import this way, which is pretty similar to how we import NumPy. It's actually built on top of numeric Python, which is NumPy, and it allows you to perform calculations that you typically perform in Excel. So you will later see we're going to be working with two types of data from Pandas. It's the Pandas series, which is very synonymous with a single column in Excel. And then we have Pandas data frame, and the Pandas data frame will be synonymous with multiple rows and columns. So a spreadsheet. So to do calculations that involve multiple rows and columns, which is what a spreadsheet is, we use Pandas data frame. And then to work with just one column, which is similar to what your NumPy array does, we use Pandas series. And you will realize more often than not, we will be working with Pandas data frames. But we'll start out the explanation talking about Pandas series. And then what is a Pandas data frame? It's just a combination of multiple series, right? So note that in Excel, the rows are indexed starting from 1. By default, in Python, it's indexed starting from 0. But in Python, you can actually determine whatever you want to call this index. You can make this index A, B, C, D, E. You can make it whatever you want. You can make it start at W. And then the column headers, which here by default is A, B, C, D, E, you will specify whatever you want in Pandas data frames. Good. So we've imported Pandas as PD. So if you want to grab anything from Pandas, say a Pandas series, you'll do pandas.series. Like so. Good. So we already know what all these three do, right? First is a list with a square bracket, right? A list of ABC. Another list that contains 3 integers. And then a NumPy array, which is an np.array, and it's created from a list of 3 numbers. So those will become floating point because by default, array function in NumPy creates floating point arrays. And then what data type is this? It has a key followed by a colon and the value. Key value. So it still contains 3 items, 10, 20, and 30, except that the keys are A, B, and C. And then you can decide whatever you want the keys to be. And so you run this is all we've done before, different data types. If you want to see it, you can use the print statements. Or just type D beneath this line, that will show. And it will always show only the last item. So if you do D and then later you ask for ARR, well, it's going to show just ARR. Very important to realize that. So what if you want to show D and ARR without using the print statement? Well, create another cell and then you can put that here. So if I ask you to display results of say 3 different data types and you type them one after each other and it only displays one, then you lose points for not displaying the other ones. It's important to put it in a cell by itself so that it's the last command in the cell. When it is the last command in the cell, then it displays it. And then this one can display D, for instance. So this will be important for displaying your Pandas series and your Pandas data frame. You will want the data frame you want to display to be the last command in each cell. And again, if you want multiple, then create one cell for each of the data frames you want to display. So we keep going, pandas.series, and then you provide the data you want to be stored in a series, and you know the series is equivalent to just one column. So it's one column but multiple rows. So what are you storing in the column? My list. And my list is 10, 20, 30. So you're going to have a column that has 3 rows, and in those 3 rows is 10, 20, and 30 stored. So that's what this gets you. You get a series of 10, 20, 30. What is this? This is equivalent to those column labels you saw in Excel. So the 0, 1, 2, 3 is equivalent to this one here, 2, 3, 4. But Python starts from 0. And then your data, 10, 20, 30, gets stored in the only column available for storing data. So these are indices, and this is your data. So if you remove this, it works fine, because by default, Pandas series expects data as the first argument. And then you'll see how that can be important. When you have multiple arguments and you don't remember the ordering, then if you specify this with the equal sign, it will always do the right calculation regardless of where you place this in the argument list, as you will see shortly. So here you see that there is the option of having a second argument. So this one used only one argument and we were fine. Here we have 2 arguments. The first remains the data and the second is the index. So you can specify the indices you want. So instead of the default behavior of having 0, 1, 2, here what do we have in labels? A, B, C. So we can label it A, B, C. And then you print it out, the 0, 1, 2 gets replaced by what? A, B, C. Data remains the same because you provided same data in the 2 functions. So by default, the first argument to the pandas function is my list. Second argument is index. So if you do this, you get exactly the same result, because by default, first argument is data, second argument is index. So we can Control Z and get back to what it was. And my point was, if you have so many arguments and you don't remember exactly the order, as long as you use this equal and then you tell pandas what each value you're providing represents. You're providing labels first instead of data first, but you have told it, well, labels is for the index and then my list is for the data. It still works because it's able to rearrange it and know to assign labels to index and my list to data. What could give you a problem is if you don't do this. So this now defaults to the standard behavior, which means it assumes labels is your data. So this 10, 20, 30 will become ABC. And then it will use your list as the index because that's the default second argument. And that's what you see here. So that's the importance of the equal sign. You can be explicit with the equal sign. So the equal sign explicitly tells pandas data frame, my list is your data, labels is your index, even though we have it in the right order, which is data first, index second. And this just explains what I showed, that my list labels without being explicit with what each of the parameters you're providing as argument is works. And then if you run this is your array, right? You're creating a pandas series and you only provide one argument. So that will be the data. And then the indices will be 0, 1, 2, and so on, depending on the length of your array. Array has a length of 3, right? So it's 10, 20, and 30, just like my list. And so the result looks exactly like the result we got before when we provided my list here instead of arrays. First argument defaults to data. You can also initialize a series with a dictionary. Now remember, a dictionary contains what and what? key value pairs. So because it contains key value pairs, it uses the key as the index and the value obviously as the data, right? So you can provide both the data and the index using a dictionary. So let's see what D is. Remember, we displayed it at the beginning here. So D is your key and value. This is what this is for the first row in the single column data, key value for the second row, key value for the third row. So the A, B, C are the keys and they become the index labels. And then 10, 20, 30 represents the data. They are the values that go into the data. And the result is that you have these as the indices and these as the data. So it's very important to understand how to initialize pandas series and pandas data frames using dictionaries. So for pandas data frames, we'll mostly be using dictionaries, and then we're going to keep using that throughout the course. So that's very important. And pandas data frames, like I said, are by far the more commonly used of the two being series and data frames. So we'll use pandas data frames a lot more because we'll be doing the kind of calculations you typically do in Excel, in spreadsheets. And it has so many functions that we operate on those data sets stored in those data frames. And I'll pause the video at this point and then start the next one focusing on pandas data frames.